Good day everyone, this is Sir Fred and welcome to another video lesson tutorial. Good day everyone. Today, I'm going to discuss to you the different measures of central tendency. But before we proceed to this discussion, let's get to know first what is statistics. When we say statistics, it is a branch of mathematics that deals with collecting, organizing, presenting, analyzing, and interpreting data to produce a useful and meaningful information. There's a lot of applications of statistics that we can see in the world around us. So just taking a look at the following illustrations, so it shows how is statistics evident in our surrounding. At this moment, let's begin our discussion to the different measures of central tendency for ungrouped data. Let's get to know first the following objectives. Find the mean, the median, and the mode of statistical data. Describe the data using information from the mean, the median, and the mode. And last but not the least, compare the mean, the median, and mode of ungrouped data. Measures of central tendency is classified into three different measures. The first one is the mean, the second one is the median, and the third one is the mode. But first, what are measures of central tendency? A measure of central tendency is a single central value that summarizes a set of numerical data. It attempts to describe what is typical in a set of data. It is more popularly referred to as the average. The first measure of central tendency is the mean, or arithmetic mean. It is the center of gravity such that the weight of the scores above the mean exactly balances the weight of the scores below the mean. It is also named as the average of the dataset, and it is solved by using the formula sum of the data divided by the number of data. So let us apply that formula in solving this example. The number of hours each student spends studying and doing a school project each day is shown in the table. We have Wilma, Jamela, Merica, Althea, Musa, Novi, and Dane. So to find for the mean amount of time the students spend studying and doing a school project, so we are going to use the formula summation of x over n. So by adding all the quantities in our data, that sums up to 26.5 over 7, and that is equal to 3.8. The mean amount of time the students spend studying and doing a school project each day is equal to 3.8 hours. In our second example, on his first biology test, Dane received the following scores: 72, 86, 92, 63, and 77. What test score must Dane earn on his 6th test so that his average or mean score for all 6 tests will exactly be 80? Show how you arrive at your answer. So not all the time, class, that mean is unknown. So in this particular problem, mean is given and we are going to identify one unknown data in the problem. So by applying the formula, summation of x over n, so substitute mean, and that is 80 equals 72 plus 86 plus 92 plus 63 plus 77 plus n. So take note that we can use any variable for the unknown. So in this problem, I use n for the unknown data, all over 6. By cross multiplication, we have 480 is equal to the sum of all the data in the numerator, 390 plus n, and applying the addition property of equality, the value of n is equal to 90. So therefore, Dane needs to get a score of 90 on his final test in order for him to get an average of 80. Let's have another example. Vic's scores in a 3-unit test are 92, 87, and 88. What must his score be on the 4th test to get an average of 90? First, let's get to know the following given. So, in our problem, the given data are 92, 87, and 88. Mean is given in the problem, and that is equal to 90. So therefore, we are going to identify one unknown data, and that is the 4th score in the test that Vic needs to get in order for him to get an average of 90. So by using the formula, summation of x over n, so substituting it, we have 90 for the mean is equal to 92 plus 87 plus 88 plus n in our numerator all over 4. Applying the cross multiplication property, we have 360 is equal to the sum of all the values in the numerator, 267 plus n, and applying the addition property of equality, the value of n is equal to 93. So therefore, Vic needs to get a score of 93 on his final test in order for him to get an average of 90. Upon knowing the first measure of central tendency, let's get to know the second measure of central tendency, and that is median. When we say median, it is the number that lies at the midpoint of the distribution of scores. Divide the distribution of scores into 2 equal halves. It is also the middle number of the set of data when the data are arranged in numerical order. And it is the value of the quantity n plus 1 over 2 item or position. So to identify the position of the median in a set of data, so we are going to use the formula n plus 1 all over 2. So take note, class, that we need to arrange first the data in order for us to identify the median. So take a look at this example. The number of hours each student spends studying and doing school projects each day is shown in the table. So to identify the median in this set of data, the first thing that we need to do is to arrange the scores in ascending or descending order. So in this particular example, so I use here the ascending order of arranging the scores. So there are 7 students, and since 7 is an odd number in this problem, so we can directly identify the middle score by applying the formula 7 plus 1 over 2, so that is equal to 8 over 2, and that is equal to 4th position. So in our set of data, just count 1, 2, 3, and 4, the fourth position in this set of data is considered to be the median. So here, the value is equal to 4. How about this example? Find the median of these scores: 17, 16, 17, 18, 30, 19, and 18. So first thing to do is for us to identify or arrange the data in ascending order. So we have 16, 17, 17, 18, 18, 19, 30. There are 70 students. Since 7 is an odd number, so therefore, we can apply the formula n plus 1 over 2, and substituting the value here, we have 7 plus 1 over 2, that is also equal to 4. And by counting, so the fourth position in this set of data is equal to the median, and that is AB. Let's have another example. Find the median for the following data: 5, 15, 10, 15, 5, 10, 10, 20, 25, and 15. So first thing to do, class, is you need to organize the data. So here I have come up the arrangement of data in ascending order: 5, 5, 10, 10, 10, 15, 15, 15, 20, and 25. So listing the data in order is the easiest way to find the median. The numbers 10 and 15 both fall in the middle. It is because in our set of data, by counting it, it is considered to be even. So therefore, there's no exact middle value in this set of data. So what are we going to do, class, is to add these two positions or two data that is considered to be the middle, okay, in this set of data. So the average of these two numbers, or the value that we will be finding upon getting the average of these two numbers, is considered to be the median of the set of data. So here we have 10 plus 15 over 2, and that is equal to 12.5. So therefore, the median in this set of data is 12.5. The last and final measure of central tendency is the mode. When we say mode, it is the number that occurs most frequently in a data. So, in short, mode stands for most often data entered. Consider this example. The number of hours each student spends studying and doing a school project each day is shown in the table. So, upon arranging the scores and asking us to identify for the mode, so the data here that appear or occurs most frequently is 4. So therefore, the mode in this set of data is equal to 4. Let's have another example. Find the mode for the following data. So upon arranging it, two numbers appear most often. So here in this set of data, we have 10 and 15. There are 3 10s and 3 15s. In this example, there are two answers for the mode. So to identify, to get the median of these two modes, getting its average results to 12.5. So since we are familiar with the three measures of central tendency, so let's include the following terminologies in our discussion. So we have here the range. When we say the range, the difference of the highest and the lowest score. And finally, the mid-range, it is the sum of the highest and the lowest values divided by 2. Let us consider solving this example. Find the range and mid-range for the following data. So upon arranging the data in ascending order, so finding the range means the difference of the highest and the lowest score. So the highest score in the set of data is 25 and the lowest score is 5. So getting the difference of the two results to 20. So therefore the range is equal to 20. The mid-range tells us to identify the highest and the lowest data, get the sum, and divide it by 2. So here we have 25 plus 5, and that is equal to 30, divided by 2, and that is equal to 50. At this moment, so let's focus on the distribution of data. So here I am going to discuss to you when does the distribution of data becomes positively skewed and negatively skewed, or left skewed or right skewed, and afterwards symmetric. So first, let's get to know what is skewed distribution. It is a distribution if one of its tails is longer than the other. Data distribution becomes skewed to the right or positively skewed if the value of the mean is greater than the median, or this means that it has a long tail in positive direction. So considering this example, observe that the value of mean here is larger than the value of the median. So therefore, this distribution has a positive skew. So note that the mean is larger than the median. On the other hand, data distribution becomes negative skew or skewed to the left when the value of the median is larger than the mean, or the distribution is a negative skew if it has a long tail in negative direction. So considering this example, here the value of median is larger than the value of mean. So therefore, this distribution has a negative skew. Note that the median is larger than the mean. Data distribution becomes symmetric if the value of mean is equal to the value of median or equal to the value of both, and therefore it has no skew. At this moment, so let's get to know the advantages and disadvantages of using the three measures of central tendency. So first, we have for the mean or arithmetic mean. So one of its advantages is that it is the most popular measure in the fields such as business, engineering, and computer science. Another one, it is a unique and there's only one answer to the problem, and it is useful when comparing sets of data. And last but not the least, it is stable from group to group. In terms of its disadvantages, so one of them is that they are affected by extreme values or outliers. So when we say outliers class, it is the value in a data set that is very different from other values. That is, outliers are values and usually far from the middle. In most cases, outliers have influence on mean but not on the median or the mode. Considering this example, getting the mean of this set of data shows that there are so many outliers or extreme values when we put it in a data distribution. And since this kind of measure of central tendency is affected by extreme scores or outliers, it is not affected or is not appropriate for skewed distribution as it is affected by extreme scores or outliers. In the case of median, one of its advantages is that it is useful when comparing sets of data, and it's more stable from group to group than the mode. It is also appropriate for skewed distributions as it is not affected by extreme scores or outliers. So take note class, we are just going to get the middle position in a set of data, and that is the median. In the case of its disadvantages, so one of this is that it's not as popular as mean, as we all know, and it is not necessarily a representative. So for mode, just like median, it is not also affected by extreme values or outliers. And also, it can be used for non-numerical data, just like colors and many more. In terms of its disadvantage, so it's not as popular as mean and median. It is not necessarily unique because in some cases we can get not only one answer. When no values repeat in a dataset, the mode is every value and is useless. And last but not the least, when there is more than one mode, it is difficult to interpret and or to compare. So class, take note of the following. The tail of the distribution pulls the mean as extreme values have a more pronounced effect on the mean than they do on the median. Number 2, distributions with positive skews are more common than distributions with negative skews. So one example is the distribution of income. Most people make under $40,000 a year, but some make quite a bit more, with a small number making millions of dollars per year. The positive tail therefore extends out quite a long way, whereas the negative tail stops at 0. Negatively skewed distributions do also occur. However, consider this plot of actual test grades on a statistics test where most students did very well, but few did poorly. It has a large negative skew. So to wrap up the things that we need to remember in today's lesson, so when we say mean or average, the sum of the set of data divided by the number of data. So do not round your answer unless directed to do so. Median is the middle value or the mean of the middle two values where the data is arranged in numerical order. Mode is the value or number that appears the most often, and it is possible to have more than one mode or bimodal, and it is possible to have no mode. If there is no mode, write no mode or do not write 0. Range is the difference from the highest and lowest value. And last but not the least, mid-range can be solved by getting the sum of the highest and the lowest values divided by 2. And by that, thank you class for listening, and God bless us all.